Welcome to video 2 of section 8.2. This is factoring by grouping. And so grouping is an interesting way of factoring something, and it usually works if you have about 4 terms in a problem, maybe 6 or something like that, but it's not going to happen in Algebra 1 where you have anything more than 4 terms that you're dealing with. So this is kind of a fun little way of dealing with something. It's kind of like making a puzzle. So here we go. Here is our first problem, and we're going to just go through the steps with this first problem, and then we're going to put them to action with the second problem. So we have 12a to the third minus 9a squared plus 20a minus 15. So to start things off, I'm going to rewrite all of these subtraction signs as adding a positive, or adding a negative. So instead of saying 12a to the third minus 9a squared, we're going to say 12a to the third plus a negative 9a squared plus 20a plus a negative 15. Just helps us see everything. So to start out with, we need to group together like terms with common variables or numbers. So if we were to look at the first 2 terms of this problem, I can see not only we have common variables, we have an a to the third and a squared, so we can take out an a squared in both of those, but I also see that the numbers are factors of, or are multiples of 3. As well, in the second half, we have 20a plus a negative 15. There's a common factor of 5 and 20 and 15, so they're multiples of 5, which is kind of cool. So we're going to group up these terms, and we're going to say 12a to the third plus a negative 9a squared. We're going to group those together, plus 20a plus a negative 15, and we're going to group those together. That parenthesis is what I'm talking about with grouping. We're just shoving them together in a nice pretty little package. So now when we're looking at those two groups, we can simply look at this group as one situation and this group as another situation. So we're not focusing on the entire problem as of right now. We're looking at parts of the problem. I try to think of this as like if I am about to tackle a ski hill, I only want to look at the first couple of turns. Otherwise, if I look all the way down the hill, I might freak out and I won't be able to handle it. This is one of those situations. Let's look at part of the problem so we don't freak out at the steepness of, or the extremeness of the problem in general. So when I look at this 12a to the third plus 9 and plus a negative 9a squared, I need to find and factor the GCF out of this. So I need to figure out what the greatest common factor is. I know there's a 3 involved because the 3 can go into both of the numbers evenly. And if I also look at here, I have a to the third and a squared, so it looks like I can take out an a squared. As well, on the other problem, we have 20a, or other half of the problem, we have 20a plus negative 15. It looks like the only GCF we have is 5 in this case. So we need to find and factor out that GCF. So let's rewrite these equations in terms of that GCF. So we can start out with saying 3a squared. So we have 3a squared, and we're multiplying that by, essentially, if I take 3 out of 12, I get 4, and if I take a squared out of a to the third, we have just simply a. And then we will have, again, 3a squared. And if I take that, if I take a 3 out of a negative 9, I end up with a negative 3. And if I have an a squared and I'm taking that away, I just simply have a negative 3. Now let's look at this other side of the equation. We're going to take a 5 out of this baby. So we have 20a, and we're going to take a 5 out of there, so 5 out of 20 is 4 is left over, and we have 4a, plus we have 5 again, and we're going to take 5 out of negative 15, so we have negative 3. So there we have found, and now we need to factor out the 3a squared and the 5. So if I were to do that, I'm going to bring the 3a squared out in front for both of these 2 terms, and this 5 I'm going to bring out in front here for those 2 terms. So we end up with 3a squared and everything left over, 4a plus a negative 3 plus we have 5 times 4a plus a negative 3. I'm hearing 4a plus a negative 3 twice, so that's ringing a bell for me. So if I look at step 3, We now need to determine our other common factors. So if we were to do that, we have 3a squared. Here's one common factor, 4a plus a negative 3. And we have another common factor of 4a plus a negative 3. So now we have determined the other common factor, 4a plus a negative 3, 4a plus a negative 3, and they are being multiplied by two very different numbers, 3a squared and 5a. So now our job is to actually do this step number 4. We need to factor out the second GCF, and as it says here, it's most commonly seen as a binomial. And that's exactly what these are. These are binomials. They are two monomials put together, added together. So we need to factor this out, and we can factor them out quite simply. So let's rewrite these equations, or this equation, plus a negative 3 plus 5 times 4a plus a negative 3. And we can factor them out in any way, shape, or form. We might as well take them to the front again, just like we have in the past. And so we will, by doing this, we will actually have remaining, we have 3a squared, oops, I meant to do the purple stuff first. We have 4a plus a negative 3, and what's remaining is a 3a squared plus 5. Cool. From there, we can easily check our work by doing the FOIL method. And so our first terms, we would multiply 4a times 3a squared. That equals 12a to the third. Our outside terms are 4a times 5, which equals 20a. We have inside terms, negative 3 times 3a squared, which ends up being negative 9a squared. And finally, our outside terms, negative 3 times 5, which equals negative 15. Putting that all together, hopefully we have the exact same solution as before, and I'm going to write them out in standard form. 20, that's a 20. A plus a negative 15, exactly the same as before. Okay, so now what we're going to do is we're going to practice another problem. Let's see if I can find it. Here we go. So 6a to the third plus 8a squared plus 9a plus 12. So with this particular problem, we are first going to group like terms. And the like terms that I see are these ones, mainly because there's 2's that I can take out of here and a's that I can take out of here. And I see commonality of 3's in this one. So that's what I'm going to focus on. So we have, I can rewrite, I can figure out now my greatest common factor for the first term. We have 6a to the third and 8a squared. So I know that there's going to be an a squared because I can take a squared out of both of those two terms. And then my other focus is maybe taking out a 2 because 6 and 8, the only common number between the two of them is a 2. If I look at this second half of the equation, I have 9a plus 12. And it looks like the only commonality they have is a 3. So I'll be able to take a 3 out of those two. So rewriting this, I can write this as 2a squared times, if I take 2 out of 6, I get 3. And if I take a squared out of a cubed, I have an a, plus, we're going to do the same thing with this 8a squared. If I take a 2 out of the 8, we have 4. And if I take a squared out of a squared, I have nothing. So I just have a 4 there. Then we're adding a 3 times 3 out of a 9, that gets you a 3, and we still have the a there, plus 3 out of 12 is 4. So when I'm saying taking things out of, remember, I'm talking division here. I'm taking numbers out by division. So now I'm looking for my new GCF. My new greatest common factor is this binomial 3a plus 4. It's in both of these terms. So this is now a term because everything's multiplying. The only addition sign that really matters is this one right here because they're multiplying. The addition sign is separating two multiplications of a number times a binomial and a number times a binomial. So looking at all this, I can now take this term and push it out to the front, and so I can rewrite this 3a plus 4. Remember, we're talking distributive property here, so we're doing reverse distributive property. Everything that the 3a plus 4 was multiplying stays behind, so I have 2a squared, and I have then also plus this 3 right here that we're going to add to the back side of that. So this is my final answer, and we can now check the work and see if we end up getting the original answer, that 6a to the third plus 8a squared plus 9a plus 12. So let's check and see if we are finished and if we got the right answer. So first terms, we have 3a times 2a squared, which equals 6a to the third. We have outside terms, 3a times 3, which equals 9a. We have inside terms, 4 times 2a squared, 8a squared, and last term, so 4 times 3, which equals 12. If I were to rewrite all of this in standard form, going from biggest to smallest for exponents, 3a to the third plus 8a squared plus 9a plus 12. So this answer that I came up with, the 3a plus 4 times 2a squared plus 3, that is our final answer because we got the same original equation. So now we're done. I hope this helps. Try the next part of the homework, and don't forget to watch video number 3. It will help you with a quick tip for dealing with problems that are super close to actually working out and teaching you how to deal with those. So I hope this helps.